Hello, physics. The problem is a stun rider on a unicycle, just a bicycle of one wheel. So this is a person riding on it. So a stun rider on a unicycle moving around a circular path. Circle. So this is circle of radius r. This is r, and this is a cyclist of radius small r. And around the circle stadium, its frequency is omega, angular frequency, angular velocity, omega. So the question is, what is its angular acceleration of the unicycle? We have to find the angular acceleration of the bicycle or the cycle. Answer is in a small interval at delta t with the angular velocity which is it changes from A to B. So this is A point and this is a B point. This is A and that is B point. B point. So it is omega 1 and this is omega 1 plus delta omega. So A to B, so is a delta omega is a change in a small angle, which is a delta theta. This is omega 1 and this is delta uh, omega, and that is say 90 degree. And then it is, we can find out that is a small angle. So delta phi or delta phi, this is a phi, is equal to delta omega over omega 1. So that the change over uh, the vector. This is the angle, but also the same thing is that it is traveling on a circumference. So this is the distance. This is arc and this is the distance, delta s. So from this one, we can find out that delta phi is equal to delta s over r. So this is the displacement. Uh, so angle from uh, angular velocity and angle from distance traveled. So from here, delta s is equal to velocity into time. Delta s is equal to vt, and v is equal to r omega. R is the circumference of the whole radius. So r is r into omega. Omega is the angular velocity of the wheel of the radius r. How much time is taken from for the stadium? This is angular velocity of the cyclist uh, for the whole radius. So if you put this one, so delta s is equal to r, and r, the v is r omega and delta t, and this is also equal to this one. S is equal to, from here, delta s over uh, r is equal to phi delta angle, this one. So this is equal to omega delta t, and this is equal to, from this number equation number 1, is this one is equal to delta omega over omega 1. So these are the two relationship we have got from this one in relationship, and this is another one, this one. So delta omega omega 1, this one is equal to omega delta t, and delta omega over delta t, delta omega, arrange this one, this is equal to omega omega uh, uh, this one over omega 1. So this is equal to, this is acceleration. Uh, this is capital omega, this is a small omega. So limiting that delta t is equal to 0. This is acceleration. This acceleration is epsilon. So epsilon is equal to omega capital over small omega, which is angular acceleration. So this is a other result. So wheel is tracing by the big circle. Delta S is equal to delta S, write down two way. So delta S is equal to R omega into delta T. This is a unicycle, and this is a big circle. So capital R over capital omega into delta T. Delta T cancel. Capital omega is equal to R from this one, R over capital, small r over capital R into omega. So from this one, but E, this acceleration, this equation, this one, this epsilon is equal to omega over omega. So this capital omega, insert substitute this value. So r omega over capital R into omega. So this is equal to acceleration is equal to r over r, small r over capital R into omega square. So this is the acceleration of the unicyclist moving around the big stadium. Its acceleration is defined by its angular velocity of the as a cycle, unicycle. So in this way, the ratio multiplied by square of the angular velocity.